In this first problem, what we're going to do is use a calculator. I have a TI-84, and we're going to approximate this exponential expression to 4 decimal places. So what we have is e cubed. So we're looking at this one, e cubed. Now I'm going to go to my calculator and I'll show you a picture of it. And like magic, here's a picture. Now if I look over here, I see this ln function, and as a second feature, let me see if I can get it here. Here's ln over here. Okay, I'll make that in red so you can see it. There's ln, but the key we want is right above it. It's this e to the x. So you have to press second. So what you're going to do here is you're going to press second, and then e to the x, and then type in the 3, and then press enter. And I got this to be equal to, let's not do that. Let's do this. This is equal to 20 point, now I want 4 decimal places, so here's what my calculator shows. 0, 8, 5, 5, and then I get a 3 over here, so I'm just going to drop it. So I think that's what we want right there. E cubed to 4 decimal places is 20.0855. We got a function here, f of x equals e to the x minus 3, and what we want to do is match this function with its correct graph. Now, here's what we do know. Here's what I'm thinking. The graph of e to the x, just e to the x itself, no minus 3 or anything else, looks like this. There's y and x, and at 0, right, e to the 0, well, that's equal to 1. So the graph of e to the x goes through 1. And then, with our work on translations, we know that, all right, the negative 3 is going to drop this down 3 units. So if I'm 1 here, it's going to go down 1, 2 more. So I'm looking for some graph that has this shape. Right, so look for a graph that has this shape and goes down here through negative 2. Right, this goes at 1, but then down 3. So if I'm at 1, there's 1, negative 2. So my best guess is, well, it's not this one. Look at that shape. We want this shape here. We want that growth shape. This looks like a decay, so it's not this one. It's not this one. That has the decay shape. What about this one? Well, this is the shape we're looking for, and it looks like it goes through negative 2 here. This one's the way up here at, what, 3 or 4? It's hard to tell. I think this is going to be the graph that we want. So I'm going to claim that C is the graph of f of x equals e to the x minus 3. Let's construct a graph of this function here. F of x equals 5 to the x plus 4. Now we know what the basic shape is going to look like. It's an exponential function. This base is bigger than 1, so it's going to have that growth feature. It's going to look like this, and from here, the plus 4, we know it's going to be shifted up 4 units. So I'm going to select the graph tool, and I think it's going to be, see over here on the right, here's where I am. I'm over here. And the tool that I want, I think, is going to be this one here. Let's try that one. All right, so I'm going to grab the graph tool and see what I can get out of this, and let's just see what happens. All right, so when I grab this graphing tool here, I see that I'm going to, if I drop it right here, now here's what I'm thinking. Come up to the top here. It's 5 to the x plus 4. Now 5 to the x, that's that basic exponential shape right there, that growth shape, but plus 4. So it's going to be up here 4 units. All right, so it's going to be 1, 2, 3, 4. All right, but when I use this tool on the right here, when I use this tool, and I even come up here and I drop it in, it doesn't matter. It's not going to drop it in there. It's going to drop it down here, like this. It's going to go through here. All right, so here's what I do. I know it's plus 4. So down here, when you get that graphing tool, you get this box. Vertical shift, horizontal shift. So take your cursor and run it over here to 4. And it'll tell you where you're at. It'll say plus 1, plus 2, plus 3, plus 4. And as you do that, this curve will move upward to 4. So now, does this look right here? You know, if I'm thinking this, if I'm thinking 5 to the x plus 4 at 0, right, at 0, now 0 is the origin, so come down here to the origin. If you put in 0, this looks like it's crossing at 5. Can we see that? If you put in 0 here, you get 5 to the 0 plus 4. 5 to the 0, that's 1 plus 4. Yeah, you get a 5. Okay, and that looks like right where we're going through right there. We know that on her 6th birthday, Melissa gets a $5,000 CD that earns 6% interest and is compounded quarterly. Now, if the CD matures on her 10th birthday, how much money will she have, will be available? Well, I'm going to use this formula right here. The amount of money is going to be P times 1 plus R over N to the N times T. Now, A is the amount that we'll have at the end. P is the principal, that's how much we're being invested, 5,000 here. And R, this is the interest rate in a decimal form. N is the number of compoundings each year. Now we're compounding quarterly, so we're going to get a 4 here. Raised to the N times T. N's the number of compoundings per year, T is the number of years, and we're going from birthday 6 to birthday 10. So to 7, to 8, to 9, to 10 is 4 years. All right, so here's what we've got. P is equal to 5,000. R is equal to 0.06. N is equal to quarterly, so 4 times a year. And T equals, what do we say, from birthday number 6 to 7 to 8 to 9 to 10. That's 4 years. So let's substitute these numbers in, and we will get A is equal to 5,000 quantity, 1 plus 0.06 over N is 4, raised to the 4 times 4 years. Okay, so my calculator, I'm going to put it in just like this. I'll type in 5,000, parentheses, 1 plus 0.06 divided by 4, close, and then I need a caret here, and I'll put in a, okay, I probably don't need the parentheses, 4 times 4. And when I did that, I got the amount is going to be 7064. Now it's money, so I'm going to go out to 2 places, but I get 869, so I'll round that up. So the amount that Melissa's going to have is 7064.87. So the question is, up here, this is not the answer. The question is, how much money will be available? Well, the amount of money that's going to be available is $7,064.87. Well, what have we got here? It says use the compound interest formula. So right away, here's what I'm thinking. A is equal to P times the quantity 1 plus R over N to the NT. And P, that's the principal. That's how much we're investing. It looks like $140,000 in this problem. R, the interest rate, 2.5%. But we're going to write that as 0.025. And N, oh, they're not telling us. But what are we doing here? Well, we'll see. I don't know N, and I do know T, though. We're keeping it in there for 7 years. So let's read this problem. Use the compound interest formula to find the account balance with the given conditions. Okay, where are all this stuff here? So here's the given conditions. P is 140,000. This is going to be compounded annually. All right, now annually, that means that N, the number of compoundings per year, is 1. We're just doing it annually, so 1 time a year. If it was quarterly, we do it 4 times a year. So let's plug these numbers in and let's see what happens here. So A will equal 140,000 times 1 plus 0.025. That's a percent, right? R is a percent, so make it into a decimal. Over N, N is just a 1 in this case, raised to the 1 times, right, N times T, and T is 7. 7. Okay, on your calculator. And I got the amount that will be available is 166,416 point, Okay, now I'm getting 0055, but it's money. So how about if I round it off to 0? Oh, I'll put a 1 here. Okay. So the amount that's going to be available is $166,416.01.